everyone. So moving into Unit 4, Lesson 4, we're going to look at how to communicate and analyze parts of a graph of a function. And so looking at this, just reminders that your domain is a set of all of your x values and range is a set of all of your y values. That is not new. We've done that before. And so what we haven't done and what we need to expand upon is then how to look at the graph itself and what is happening during that graph and in between. So we look at different intervals and we say that a function is increasing as our x's, we plug them in and the values get larger, and then decreasing if we plug them in and the values are getting smaller. And then we have local maxima, which are the peaks or the mountaintops of a function, and local minima, which will be the valleys or the bottom of a function. And so we can look at this graph over here to the right and identify some of those key components. So hopefully, just based off that definition, you can kind of tell that it's increasing along this interval here. This would be increasing. And then it decreases from there to here. And then it once again increases from there to there, so it's increasing. Okay, so you can kind of see when it is going up, when it's going down, when it's going up, so that's your increasing, decreasing. At the top of that increasing, before it starts to increase again, so right where it turns, where it goes from increasing to decreasing, this is your local maxima, all right? Where it goes from decreasing to increasing, that second turning point is your local minimum. And it may have more than one of each of those, and that is fine. But those mountaintops are your maximums. Those valleys or those low points are your minimums. Okay, so you're looking for turning points in a graph when you're looking for those things. Okay, so you can take a minute, pause the video if you need to finish writing that stuff down. All right, so we say a function is increasing or decreasing over an interval of its x values. So when we're describing those values and we're giving that interval, we give the x values specifically. We don't worry so much about what those y values are. Okay, we are going to be consistent with notation. Our book, if you have been following along at all, uses closed intervals all of the time. We are going to always use open intervals when we describe this. So we're going to use parentheses every single time. And we only use the x values in them. We're never going to worry about our y values when we're talking about your intervals. Okay, so only use the x values, always describe it as open, so parentheses. All right, so let's go ahead and look then at a function here. Remember, your domain goes from left to right. We're looking at just the x values, excuse me. And so this doesn't have the arrows, but we're going to assume they're there. This one gets wider going left and wider going right. And so it is all real numbers, or in interval notation, it would be negative infinity to positive infinity. Right? Every x value is covered. Your range, though, you have to find what your high point is when you're looking at your range. And so here's the highest point. I'm looking at my y values only. It goes forever in the bottom direction. But it tops out right here. And so my range is going to include negative infinity, but it's going to peak out and have a high point, and we need to just know what that point there is. So there's 3, sorry, this got off a little bit, 5, 6, and 7. So my high point here is 7. That is included in my range. It's not an open circle or anything, so I use a bracket. okay? And so that's your range. Then we can look at when is it increasing and when is it decreasing. So this one is increasing. It's going up right here and right here. And so remember we described those intervals, and we're going to use the x values. So it's increasing from negative infinity to whatever this x value is. So this is 2. And then we skip over this part where it's decreasing. It starts increasing again here at 4. Uh-oh. Starts increasing here again at 4 and goes to 5. And so it's increasing from negative infinity to 2, and then again from 4 to 5. So that leaves the other intervals where it would be decreasing. So it's decreasing here, it's going down, and it's decreasing here, it's going down there as well. And so it is decreasing. It started at 2, and you'll notice hopefully that those numbers are going to overlap there, because once it peaks out, it will start decreasing again. And it stops at 4. So once again, we're repeating that value. It started increasing again here. This is why we use open intervals, because we don't really know which number that one is included in. It starts decreasing once again at 5. Again, that overlap of those numbers there, and it's going to go all the way to infinity. Okay, so that's your decreasing intervals on that one. Constants, remember constants are when it doesn't change, so it's neither increasing or decreasing. You might have something like this where it flattens out. There's nothing like that in this graph, so there is no constant. Okay. Pay attention to those minimums and maximums. We have one here at 2.7. We have a max, and we have another one at 5.6. All right, we have a minimum down here at 4.2. It didn't ask for any of those here, but just be aware that those are also on your graph. Okay. You can kind of see the range value in that. You can see some of your increasing and decreasing interval values in there as well. Okay, when you're talking about the x values. All right. So I'm going to have you go ahead and pause the video and try this one on your own. Same thing, looking for domain, range, the increasing and decreasing intervals, and any constants that you may have. Okay, you can go ahead and check your answer here. Domain and range in this case are both all real numbers, or negative infinity to positive infinity. It is increasing from -2 to -2/3. There's a reason why they gave us that coordinate, because otherwise we would have to guesstimate here. So it's increasing along that interval. It's decreasing on your other two intervals from negative infinity to -2, -2/3 to positive infinity. All right, there are no constants in this graph, and so we don't need to worry about that. Okay, so just practicing graphing some on your graphing calculator. Okay, so if you type it in your graphing calculator, you get an image like this. So we can just kind of give a rough sketch of that same thing on our paper if you don't have a graph provided. And so it was, let's see, it crosses at like a little here. So something like that. So we're not exactly perfect, and that's fine. We don't need to be. Now, hopefully you've recognized the fact that this domain and range would be all real numbers. However, this one, just like a piecewise function, has what's called a domain restriction. So anytime you see this stipulation, it's restricting your domain. And so that is actually what your domain will be. We're going to use brackets because we have the lines underneath, and so we have -1 to 4 bracketed. Okay, and that's our domain. To find the range, we would either need to specifically plot all of these points instead of just doing a rough sketch and not put the arrows, just restrict it from -1 to 4 and put all those values, or we could just plug it in. So that's what I'm going to do. We're going to find f of -1, and that is -1 cubed minus 2 times -1 squared plus 1. So if you solve that out, you get -2. And so instead of actually having an arrow here at -1, you'd be at -2. And so this is -1, -2. That's the lowest point on this side, so that'll be a local minimum. Then we're going to find f of 4, plug that in the same way, and solve it out. And you get 33. So by the time we're over here at 4, so some point way up here is at 433. This probably keeps on going forever, right? So it's not really a maximum value of our graph. Likewise over here, it's not really the minimum value of this graph, but it does tell us that our range for this domain restriction is starting at the -2 and then goes to 33. So -2 to 33. Okay, so that is just because of that domain restriction, and that's the only reason. So keep in mind when you graph on a graphing calculator, it doesn't put those domain restrictions in place, so you still have to figure that aspect out. Okay, so we're going to see this graph here and do the same thing. Identify our domain range, increasing, decreasing, and constants. Now this is a piecewise function, so you do have to be careful and look for any gaps in your graph when you're doing this. So remember that closed circles trump open. So we're starting out here going left to right. This starts at -5, there's nothing else. And we go over, here's an open circle, but right down here it picks back up, and so we're okay. We keep going. But then there's a jump in our graph. There is nothing in our domain from here to here. So this is the last value in our domain from left to right until we get to this open circle here. And then we go, here's closed. Here's an open circle in our domain. So we go from there to there as well. So we can see left to right here, erase kind of all these extra lines. We're going from -5 to 0, and then from 1, keep in mind that's an open circle, all the way to 6. And that would be how you describe your domain. So your domain is expressed like that, where you're going from -5 to 0, and then you're skipping from 1 to 6. Noticing that we use parentheses because the 1 and the 6 are both open circles. Okay? Your range, we're going to do the same thing. We're going to look at your y-axis going up. And so our lowest value is here at -2. And we continuously have something all the way until this +2 here. And then it skips and we have another value at 3. We don't have anything above the 3 or anything below the 3. So looking from bottom to top, always least to greatest when we're doing domain and range. We're starting at, again, the -2 with an open circle. We're going to +2 with a closed circle. So unit 1 coming back in here. We're joining that with a single value. So we're going to use braces to show that 3 is also included here. Oops. In our range. Okay. Increasing and decreasing wise, this one looks a little bit different. Remember, when we describe increasing and decreasing intervals, we're describing our x values and what that function is doing from your x values. So I just start left to right here. So our furthest left value here, we're decreasing all the way to here. All right, so we're decreasing from -5 to -2. Always just use parentheses here. Then we're increasing from -2 to 0 using those x values. All right. There's nothing in here. From 1 to 4, we're neither increasing or decreasing. We're staying constant from 1 to 4. Sorry about that. Staying constant from 1 to 4. And then once again, we're going down. So we're decreasing from 4 to 6. All right, so decreasing, constant, increasing, decreasing. Okay. Okay, so as far as applications go, this one you would just do kind of the same thing, describe what this means in terms of what's going on here. So we have time in hours and distance from home. This is something you might see on a standardized test of some sort. So as the time goes on, how far away from home are you getting? What does it mean when you have a constant in terms of when it's increasing or when it's decreasing? We can talk about applications later on, but just keep in mind that's essentially the discussion that we're going to have. Okay, what does it mean when a graph is constant when you're talking about time in terms of distance? Okay, and so moving on to local max and local mins. Remember that your peaks are your local maxima and your valleys are your local minima. We already covered that on the previous page. But note that your maxes and mins cannot occur at an endpoint. So I'll just reiterate that here. We're talking about in the middle of a function, where are the peaks and where are the valleys? So we're not talking about endpoints of functions because they don't typically have endpoints. So if you have a domain restriction and it's stopping the graph, we're not going to consider that a minimum or a maximum. Okay, so again, here's a maximum. You have something like this. This is not a maximum. Sorry, I kind of went off the screen there. All right, so looking at a couple more examples here in terms of just your local max and your local min. So we already talked about increasing and decreasing on all of that. Just looking at local maxes and min. All right, so local max we write in a specific way. We're going to say the y value first. And so this one is at 7. So we will say at 7 when x equals, and then we find the x value here is 2. All right, so the second one here, remember your local maximums are all of your peaks and those little mountains. We'll say at 6 when x is at 5. Okay. For your minimums, we look for those valleys. So here is your minimum. Again, we say at, and we say the y value, 2 when x is at 4, or x equals 4. Okay. So go ahead and try this next one. Okay, and you get at 7/3 when x is at -2, and then at 0 when x, excuse me, -2/3, and then at 0 when x is at -2. Okay. So you can also find your local minimums and maximums if you graph these in a graphing calculator. Okay, so type this in a graphing calculator. I zoomed in by changing my window. You can see my window settings here. I set the min and max, and then I put my scale at 1/2. just so this would get a little closer, otherwise it was pretty small. So your local minimum, remember, can't be an endpoint, so this one actually doesn't have one. Your local maximum is this peak up here, and you can just, like I said, kind of eyeball that. So, or you can hit second trace, and we want to find a maximum. So we're going to go down to maximum or hit the number 4 would also work. And then you're just going to say, it's going to say left bound. So you want to be on the left side of your maximum value and hit enter. Then it'll switch to right bound. You just need to go to the right side of that maximum value and hit enter. And then if you hit enter again, it will calculate that maximum for you. So the maximum is at 0.32 when X is at 7.5. So we can say, oops, the max is at 0.32 when X equals 0.75. The min, there is none. It is increasing from 0 to 0.32. Remember, we use X values here. And then it is decreasing from 0.32 to, and let me look back at my graph here. My last X value here looks like it's a 1. So it's going to 1. All right, so using X values, when is it increasing and decreasing? I rounded this as 2 decimal places, so I went out to the 100th spot. All right. So just to summarize, remember maximums or minimums are your mountaintop or valley of your graph. Okay, so max or min is the mountaintop or valley of a graph. If I say the max or min value, we're talking about an X value that corresponds to the max or min. And then if I say the max or min is at, then we're talking about the Y value. So notice the difference here that corresponds with a max or min. Go ahead and see if you can fill out this general info for this graph, just based off of what you know about functions so far. Okay, so to find a value of a function, you look at the graph where X is equal to A, right? And so if we're looking for f of 2, we look where X is 2, and then we look up at the graph. This one was a little bit mislabeled. This should have been 3. So if we count 1, 2, 3, 4, 5, 6, 7, 8, f of 2 is 8. Same thing with 5. We look at the 5, we follow it up. Then what is the y? It's just one below that, so 7. So f of 2 is greater than f of 5 in terms of that function. And that is it. Let me know if you have any questions, and have a good night.